In this tutorial, I'm going to talk a little bit about logic in Grasshopper and how to do things onto certain geometry or certain data and how not to do things onto other geometry and data. So a very quick example, I'm going to create a list of numbers in a panel, and when you do this, make sure that you click on multi-line data so you get these stripes, which essentially is telling us that this is a list of numbers instead of one single piece of data. I might as well start from 0 because all software programming languages, all numbers, all things start with a 0. And I'm going to use the modulus component. Modulus is the remainder of a number when it's divided by a number. So if I do this divided by 3, modulus will not give us, what the number is. If we put in 9, it'll say 9 divided by 3 is 3, remainder 0. So the output is actually going to be 0. So here I get the modulus of the remainder. And let's say I want all the numbers in which the remainder divided by 3 equals 0. So I'll use the equality component. I'll actually plug the first number to the second number, or rather the right data and where it should go. And so now we have this true-false list of when things should be false and when things should be true. So only when this number is 0 is this true, and when this is 0, the remainder is 3. So this will give us, hopefully, all the multiples of 3. And one thing I did on purpose wrong is don't actually use the panel to plug things in. This is a minor thing, just plug them directly. And the reason why that is the panel component will sometimes turn your data into text, and that will kind of fail or be confusing at the most inopportune of times. So make sure you don't go through, go directly. Now we're going to use this component called the dispatch component. What the dispatch component does is it takes an input of a pattern, of a true-false pattern, and these are called Boolean values, by the way, true or false values, and it takes a list of data. So let's say I go from this result. So what it's going to do is it's going to divide based on the pattern, whenever this was true, so true, false, false, true, false, false, it's going to take this result, and out of list A is going to come out all of the values from the list at which the pattern was true, and so list B is all of the values that don't equal 0, list A is all the values that do equal 0. So dispatch you can see when you hover over the icon here, it kind of gets a list and sifts them or divides them into two different lists. But the input list I can not only take from here, but I can take from go upstream, because all of my data is in the same order and they're kind of all flowing through these components. I can take it from this point, actually. So now, out of this dispatch, I'm getting a list of data in which the remainder divided by 3 is not equal to 0 or equal to 0. So here, you can see we get all the list of numbers that are divisible by 3. There's another component, actually, as an aside, called sift pattern, which is almost exactly the same. The only difference in behavior is that what comes out of the output, and the order of these are switched, by the way, so what comes out of output 1 is when it's true, when the sift pattern is true, output 0 is when it's not true. We have the same values, 0, 3, 6, 9, except there are null values inserted in between them, which means that they're exactly the same, in exactly the same order as the input data. And this can be especially helpful because in Grasshopper, the order of the data in which things go is pretty valuable. You can imagine, say, doing an operation in the first piece of data, only having this entire set of data flow through a lot of things, and then at the end, if all the orders of your operations are matched up, then the first piece of data in your result corresponds to the first piece of data in the input, and then that way you can kind of match a lot of different logics up to geometry, etc. So sift pattern preserves the order, dispatch doesn't care. Of course, you can get from sift pattern to an output like dispatch by doing something like clean tree, which if you plug it into tree, removes all these null points. So this now looks like this, 1, 3, 6. So there, you could remove the nulls if you want, but sift tree is valuable because it doesn't do that and it preserves the order. So this is kind of a quick, the most elemental example of true-false kind of values. And let's say I want to do something a little bit more explanatory. Let's say what I actually want to do is I want to create a series of points and a boundary, and I only want to get the points that are inside the boundary, and I want to create the trees on those points. Now, if you notice up here, what we did is we had a true-false value, and then we did a dispatch, and that's kind of a good, really important building block. And so I've translated, actually, getting the points that are inside the boundary actually consists of this process. Getting a true-false value of is a point inside of a boundary, question mark, and then doing a dispatch component. And this is my pseudocode in which I've written out by hand what I'm going to do, instead of actually just coding instead. So, okay, that seems like a pretty good approach. Let's actually enact that in process. What I'm going to do is I'm going to create a boundary. I'm going to use my trusty geometry pipeline component, created a layer called point. I'll make sure it looks at that point. I'll double click on this so we're getting a point. I'll make sure that the highlight is on this layer. And then so when I create a bunch of points, you can see that they're already being loaded in Grasshopper because there are X's around them. Oops. Component. By the way, in order to do that, I'm holding Shift. I'm doing using the quotation mark in order to instantiate a panel. So I have a bunch of points and a piece of geometry. Now next for this true-false, is a point inside of a boundary? Well, this is actually an evaluation of a point or a curve, and I happen to know that it's in this analysis component because we are analyzing a curve. It's actually down here, point in curve, point in curves. This is for multiple curves, this is for one curve. Really doesn't matter, so I might as well use the point in curves anyways. I'm going to put in a point, and put in curves. And what comes out of here is the relationship, and the relationship is a series of numbers. If I hover over the relationship, it says 0 equals outside, 1 equals coincident, 2 equals inside. So essentially, when the point is on the line, it gives us 1. When the point is inside, it gives us 2. And I'm going to, so what I can do here is I can say, okay, when is the relationship equal or not equal to 0, or when is the relationship equal to 2, and then use that to get our true-false values. I can also do this kind of a trick. So in computation, all, kind of the history of computers, all zeros mean false, and all non-zero values mean true. So what it basically means is I can try to turn this into a Boolean value, which is a true-false value, and Grasshopper will be helpful and turn 0 into false, and 1 or 2 or anything else into true. So when I plug that in, you can see it's already done that for me. And the reason why I've done this is because it just skips the step of us not having have to worry about having another, like, is this equal to 0. This will also be helpful later. And it's helpful to know why this happens, because Grasshopper is taking a number and turning it into a Boolean type, so it's kind of molding, or what in computer science called casting the information into a new type of value. Either way, we've just kind of done this little bit of magic. And now we have a series of true-false values, and I'm going to use the dispatch component to plug the dispatch pattern into the Boolean, the Boolean into the dispatch pattern, and then I'm going to use the initial points as my list. And now I get geometry of the points inside and geometry of the points outside, which is great. And now all I have to do is create my trees on points. For the sake of time, I'm going to have my quote-unquote trees just be kind of extruded geometry. Hopefully, you can fill in the blanks. These are very complex buildings, pieces, things, but hopefully this makes sense. So now I have a logic in which it will only grab the points that are inside the curve and do something with it. So here's a kind of good fundamental. But let's say that's not enough. I want to do one more thing. I want to also say only that, but when the points are, say, lower than the z equals 0 plane, when they're underground, say, I want the tower not to exist. Which means essentially I'm setting up two different overlapping types of geometry, types of logic. So what I'm going to do is I'm going to deconstruct the point, and I'm kind of talking my pseudocode out loud here. And I want to say, okay, when is that z component, the z value, smaller than 0? Because if it's smaller than 0, it's underground / below the z equals 0 plane. And actually, before I do that, I'm going to move my points up and down just so that we have a little bit of like variation. Otherwise, we'd have pretty boring data. Okay, that's pretty good. Oops. Okay. And so this also has a true-false value. And so now we have a true-false value here and true-false value here. And we want to have it so that when both of these are true, only when both of these are true does this tree appear. So I'm going to introduce really briefly what's these Boolean operations. And by the way, they're in math and in operators. And if you go down here, there are all these different gates. And this is a little bit the fundamentals of computer science right here, or the fundamentals of classical logic. So AND is this gate that basically says only when both its input A and its input B are true, does this become false. So if this is true, or only this is true, it's false, but only when both are true, our output is going to be true. You can probably quickly imagine that the gate OR does something very similar as well, but with a different logic. If only one of these is true, then the output is true. If both are false, it's false, but if it's false and true, or if it's true and false, the output is true. There's another gate not even simpler. Essentially, if it's false, it becomes true. If it's true, it becomes false. And then there are other gates like XOR, which you probably won't use, but it's kind of fun to talk about. Only when the inputs are different is the output true. So if it's true and false, it's true. If it's false and false, it's false. If it's true and true because they're not different, it's false. But you'll probably end up mostly using the first three things. And up here, if you think about it, what we want is we want both the point to be in the curve and the point not to be smaller than 0. And actually, instead of smaller than, I'll use the component greater than. So the first number is greater than 0. I'm going to use the AND component, and I can use, so I'm going to plug this and this, and now we have a whole series of different Boolean values, and if I plug this into my dispatch, now we see this point is inside this line, but it's lower than z equals 0 plane, the z equals 0 plane. And now this point is high, and inside it works, but if I plug this outside, now the point is up high, but not inside the boundary. So only when these two overlapping series of logics operate at the same time as an AND do I get what I want. So, I could add another piece of logic and actually do another AND and another AND and another AND. So I could have many different requirements that all intersect, and only when all those requirements intersect does something happen. So that's a kind of a pretty good example of how to add logic. Do this and not that. The other thing I will show you, I'm going to create spheres around each point. So we have points, and we also have spheres around these points. And let's say I want to color these spheres. So what I've talked about so far is, we have pretty much this fundamental building block. I'm going to get rid of this for convenience sake. We have a true-false generator, a test that says yes or no, and then a dispatch component or a swift component that divides it into two. But what if we want the inverse? Instead of using a true-false value to split data, what if we want a true-false value to choose between different types of data? So here's an example I'll use. One is, let's say we have two different colors, and we want to color the points inside, or the points that are working as green, the points that are not working or non-ideal as red. Kind of universal language for stop and go. And what I'm going to use is a component called pick and choose. And it kind of does what it says on the tin. It sounds, you have a series of input data, and the pattern actually lets you choose between these two streams. The thing about these streams is that they have to be the same length as the pattern. So let's say the result of our AND plug into the pattern, there are 42 pieces of geometry, the 42 true-false values, and so we want our stream to be the same length. So what we're going to do is we're going to use the list length component, which essentially says how long is our list, and it says, oh, it's 42 items long. And then I'm going to use the repeat data component that essentially takes a piece of data, whatever it is, and just repeats it over and over again, 42 times in this case. So you can see that we have 42 pieces of repeated data. I'm going to do the same with red. And so now we have 42 pieces of repeated data over here. I'm actually going to switch the positions of red and green. So now we have a pattern and we have a stream. We have a stream of the red color and the stream of the green color. And whenever the pattern is 0 or false, stream 0 is going to come out. So when the pattern is false, the red is going to come out as a color into the result. And when it's true, the green is going to come out. And so you can see that now we've kind of weaved together these different colors of red and green and red and green. And now I can use a preview, a custom preview component, to grab the geometry and use this color. And now I've colored my geometry, all my geometry, my 41 pieces of geometry, 42 rather, based on 42 different colors. The 42 different colors come from one color that was repeated 42 times, but sifted or picked and chosen based off of a pattern. That pattern comes off of this calculation, which is the summation of these calculations, which come from initially the geometry. So we know that the geometry, the 42 pieces of geometry, the points, are in the same order because I haven't done any kind of like, I haven't turned them out of order or removed certain parts of the data, which is why this can happen. So now how it feels is, I move all these points around. And I have this way of combining different logics or different pieces of data based on a logic. That's where I'll end this tutorial, which is more about the simple data flow. But I would encourage you to look at different components. Pick and choose, dispatch, sift pattern are all really helpful. Dispatch and sift pattern, and also stream gate. And I won't explain this in this video, but these will all take a list or stream, and then just explode them out into two different kind of outputs. Pick and choose and stream filter will do the inverse, in which they'll take a pattern and then multiple different inputs, and then kind of pipe them out into one singular output. And so you can imagine that this is oftentimes used for, I know what I want, can I separate A from B? And this is more like, I know my logic, can I synthesize new data using these rules? And using that, you can pretty much start to implement most, if not all, of the logic in Grasshopper.